Hi students, welcome to homework number 7, question 4. In this problem, we're being asked how much of each starting material we would use to prepare 2 liters of each of the following solutions. So in part A, we're making a solution that has a molarity of 0.330 molar, and we're starting from solid NaOH. So they want to know the grams of solid NaOH we would need in order to make 2 liters of this solution. In all of these problems, we will basically be using the definition of molarity again. Molarity is moles of solute divided by volume of solution measured in liters. But often, we'll be interested in the moles of the solute. And so we will be multiplying molarity times volume to get the moles of solute. In part A, since we need to know the grams of solute, the mass of the solid NaOH, we'll have to calculate the moles of solute first. So moles of solute is equal to molarity times volume. Our molarity is 0.330, and our volume is 2 liters. So 0.330 times 2 is 0.660. That's how many moles of NaOH I have to make that solution. They want to know the mass of the starting material. So we have to change the moles of NaOH into grams. So one sodium atom has a mass of 22.99. One oxygen atom has a mass of 16. One hydrogen atom has a mass of 1.01. So when we add all that up, we get 40.00. So we'll take 0.660 moles of NaOH and multiply it by 40 grams of NaOH in 1 mole. .660 times 40 is equal to 26.4. So we'll have to weigh out 26.4 grams of NaOH in order to make 2 liters of the 0.330 molar solution. In the next problem, we are making a dilute solution from a solution with higher concentration. So our dilute solution that we're making has a molarity of 0.230. And as before, we're going to make 2 liters of it. We're starting with a solution that has a higher concentration, one that has a concentration of 1 molar. It's a stock solution. So it's a solution that someone has prepared and left in a stock room so that it can be diluted to make a variety of other solutions with lower concentration. If we're doing a dilution problem, you may jump right away to M1 V1 equals M2 V2, but just as a reminder, it's important that you know where that comes from. When you're making a new solution with a lower concentration from an older solution that has a higher concentration, the key thing to remember is that the moles of solute before the dilution are equal to the moles of the solute after the dilution. This is because before the dilution, you're going to take some portion of your stock solution out. And when you take the portion of stock solution out, that portion contains a certain number of moles of solute. And then you're going to take that portion and put it into a new container. And after that, you're just going to be adding water. So you won't be adding any additional moles of the solute. So the moles of solute that you take before the dilution from the stock solution are equal to the moles of solute that are in the new solution, even after you dilute it, because when you dilute it, again, you're only adding water, you're not adding any additional moles of the solute. So the key thing in a dilution problem is that moles of solute before the dilution equal moles of solute after the dilution. So that's where this equation comes from, because moles of solute before the dilution is M1V1, moles of solute after the dilution is M2V2. So before the dilution, we have a 1 molar solution. And we don't know how much of it we need. We don't know how much of it we're going to take. After the dilution, we're going to have 0.230 molar as our concentration. And we know that we want to make 2 liters. So we're going to solve for V1. Which is 0.230 times 2 divided by 1, and that is 0.46. 0.460 with 3 sig figs liters is equal to V1. So this is telling us the volume of the stock solution that we must remove and dilute to 2 liters. You see the needed units are liters, so I will enter 0.460. The third problem is like the first one. We're going to be making a 0.4 molar K2CrO4 solution, that's potassium chromate, and we'll be making it from solid potassium chromate, as in letter A, where we were making it from solid sodium hydroxide. All 4 of these, again, 2 liters of solution. So this one is very similar to part A. The moles of solute needed are equal to the molarity times the volume. The molarity that we're going to be making is 0.4. We're going to be making 2 liters of the solution. So we need 0.8 moles of the solute. We need to multiply 0.8 times the molar mass of our solute. So potassium is 39.10. We're going to double that one. Chromium is 52.00, and oxygen is 16, and we want to multiply that by 4. So that's 194.20. That's what we're going to multiply by, 194.20 grams of potassium chromate in 1 mole of potassium chromate. So 0.8 times that molar mass is equal to 155.36. I think we can only have 3 sig figs, so we'll call that 155. 155 grams of K2CrO4 are needed to make 2 liters of 0.4 molar potassium chromate. The fourth problem is similar to part B. We're making a dilute solution with a concentration of 0.18 molar from a solution that has a higher concentration, a stock solution of 0.175 molar. So since this is a dilution problem, we'll use M1V1 equals M2V2. The original solution has a concentration of 1.75 molar, so that's M1. We don't know how much of that we need to take, that's what we're solving for. The solution that we're making has a molarity of 0.180. We're going to make 2 liters of it. So V1 is equal to 0.18 times 2 divided by 1.75. That's equal to 0.2057. Let's call it 0.206 liters. So again, they want the answer in liters, so 0.206 liters. 0.206 liters of 1.75 molar K2CrO4 solution will be removed. And diluted to 2 liters total solution. And that new solution will have a concentration of 0.18. Okay, thanks.